Professor Heiner Linke, member of the Nobel Committee for the Chemistry Prize. How could you explain this year's prize, please?
So this year's prize is about a discovery called quantum dots, and they are extremely small particles, so small that if you imagine a soccer ball, how small a soccer ball is compared to the entire planet Earth, a nanoparticle is that small compared to the soccer ball. So it consists only about of a few hundred or thousands of atoms. And the key thing, the cool thing about quantum dots is that just by changing their size, having a few hundreds atoms or one atom layer more or one atom layer more, you change their properties, for example, their color. Now this is completely unusual because normally, if you imagine, for example, you want to dye t-shirts, a red one, a green one, a yellow one, a blue one. For each of these colors, you would use a different molecule. Different atoms in different constellations give you different colors. That's what chemistry is all about. But in quantum dots, you can use precisely the same atoms in the same constellation and just change the size, how many of the atoms you have, and get new colors and new other properties. The reason for this is a quantum mechanical effect. In quantum mechanics says that particles such as electrons are also a wave, and for an electron to live in a small nanoparticle, its wave needs to be compressed as you make it smaller and smaller, and that changes the properties of the whole material.
And how does this quantum dots actually affect our life?
So the place where you can find them in real life is, for example, in some of the very best TV screens, when you have particularly bright colors, when you have particular high definition. One of the ways of making this is to use quantum dots as the color giving. So you have pixels, the number of pixels tells you the resolution of the screen, and the pixels then consist of red and green quantum dots and the blue light from the back that controls those colors. That is one application. Another one is in LED lights. I guess we are all familiar with LED lights that are not so nice, that are a little bit bluish. Quantum dots can be used to make that light really nice. So you can almost resemble sunlight, for example, by mixing the dyes. They are basically used as dyes then to turn the blue light that originally comes out of the LED into something that we perceive as really pleasant. That might even help us to focus better or to sleep better, or depending on the time of the day. So this is a little bit of future application, but you can also already see that. Maybe a little bit further away, we see already quantum dots using for biomedical imaging. That's a lot in research, but for example, to look at tumors and understand better how they are built up, how they work, or how the inside of cells work. It's a way of visualizing what's going on inside. So these are a number of examples.
So there are a lot of applications.
Yeah, but the key thing is we believe that the real big applications are still in the future. So quantum dots can be seen as one milestone for the whole field of nanotechnology, which is really about using new properties that happen at these new scales. And we believe that many new applications are still coming. So this is much might still be in the future.
So there are 3 laureates. Could you tell us something about the phone call, this magic phone call in the morning?
Okay, so yes, we have 3 laureates. One we didn't get hold of. Lou Bruce didn't answer the phone. Munji Bawendi answered the phone. He was surprised and he was clearly surprised and honored. So he had gathered himself by the time of the press conference. Alexei Yakimov, he lives on the east coast of the United States, but I believe we caught him. He was somewhere else, and if I understood him correctly, he was in Mexico. So maybe on vacation, I don't know. But also he was clearly surprised and very happy.
So if you would summarize this prize, where you are so excited about it, in 30 seconds, what would you say?
It's about the discovery that with relatively simple means, with the means of chemistry, on a benchtop, can make perfectly controlled small particles to such a control that you can use the laws of quantum mechanics to change material properties. And I would call it a foundational discovery of nanotechnology, which is about using new phenomena that happen at a small scale for applications in many different areas.
Thank you so much, Professor Heiner Linke, member of the Nobel Committee for the Chemistry Prize.
Thank you very much. Pleasure.